So we're going to take a deep dive here into the idea of integration by substitution. And I think this is a really good problem to look at because it's so intricate, it's kind of abstract, it's notational, and it's not traditional. So typical multiple choice question, but atypical idea here. Which of the following definite integrals equals this f of g of 4 minus f of g of 2? So the key here, right away, just in terms of like what to recognize, is the idea that we're dealing with composition. And so composition, for us, at least in calculus, should raise red flags because that usually indicates some variation on the chain rule. And that really is where integration by substitution comes into play. It's really integrating some function that appears on a chain rule level. So when we look at these answers, and it can be super overwhelming, we have to think about what do they have in the integrand. Remember, the integrand is the thing inside the integral symbol, right? What do they have that we can integrate, and thereby, once we evaluate using the fundamental theorem of calculus, once we plug in the upper bound and the lower bound, gets us to here. So the problem with A is that if you integrate f prime, yes, you get f, which makes sense, but what do we do with this g in here? And the other issue is, since g itself is a function, there's no indication that g's derivative is in the problem, like it is in C and D. So that should kind of give you a little bit more indication that that's kind of where we need to look, right? So the problem with, so you can kind of eliminate A and B from that. If you don't feel good about that, we'll kind of solidify that in a minute. But the problem with C is that if you're starting with f, that's great and all, and the derivative of g is certainly g prime, but integrating lowercase f would lead us notationally at least to uppercase f, and that really is not in line with what they're asking. So let's look at D, and here's where the secret lies. If we were to let u equal g of x, then du equals g prime of x dx. And we notice that, well, wait a minute, there it is, g prime of x dx. So we talked about a lot that one-to-one match that we're looking for. So imagine if I were to rewrite this, we'll get back to the bounds in a second. Now it looks like something I can integrate. I can integrate f prime, it becomes f. Question is, what do I do with the bounds, right? Well, we talked about needing to know what to make u of 2, right? These bounds would change, so to speak. Okay, well, u of 2, according to what we did up here, would become g of 2, and u of 4 would become g of 4. Well, guess what? Look at the original question, starting to take shape here. So the actual integral would be the integral from g of 2 to g of 4 of f prime of u du. And if you actually go ahead and integrate that, you get f of u evaluated from g of 2 to g of 4, and sure enough, you get f of g of 4 minus f of g of 2. So this might have helped you, it might have confused you even more, but I really wanted to take a look at that idea of, is the function's derivative sitting inside the problem?